Welcome back, explorer of ages and mysteries, no matter where life finds you, or what time it is right now. Thanks for being here with this peaceful pause. Just breathe, relax, imagine your thoughts sinking deep into the earth. Should these explorations of our world's secrets resonate, a simple tap to show appreciation helps. Also, share where and when you tuned in. Deep under Yellowstone's quiet woods, where the air barely moves, a colossal thing exists. It wasn't alive, not like anything known. More a pulse within the earth, a room made of flowing rock. Down under everything solid, a fiery core beat. The world seemed calm for ages. Animals wandered, hot springs puffed steam, waterways curved through old lands. However, deep down, the planet's first power stirred. Yellowstone isn't just pretty scenery. It's a reminder of immense forces. A huge volcano slumbers under those peaceful fields. One of Earth's biggest still stirring today. They label it a supervolcano, a term sparking wonder, yet hinting at something unsettling. While we picture space rocks as threats descending from the sky, Yellowstone suggests an upheaval brewing beneath our feet. Long ago, before Yellowstone became a park, continents drifted. The North American landmass crept west, barely faster than how long it takes your nails to lengthen. Underneath, heat welled up from inside the planet, a tower of molten rock pushing upwards. The land drifts over a hot spot deep below, leaving behind old volcanic craters, evidence of colossal blasts. These eruptions once showered vast stretches of America with ash. Beneath Yellowstone lies a restless heat source that has blown its top thrice over the past 2 million plus years. Its initial outburst, some 2.1 million years back, proved enormous, a truly massive event in our planet's story. A shift occurred around 1.3 million years back, altering the landscape once more. Subsequently, about 640,000 years later, Yellowstone caldera formed, an immense basin exceeding 30 miles across, so large its boundaries remain hidden from view within. With time, the landscape recovered. Trees flourished, the world chilled, then warmed again. Life bloomed anew, oblivious to the fiery sea hidden far below its feet. A molten expanse going on forever. Scientists aren't worried about an immediate Yellowstone eruption. Nothing suggests one is coming. However, its potential, the sheer power to reshape Earth, air, even how we measure years, is what gives them pause. Yellowstone going off big wouldn't resemble any volcano people have actually seen. Think less about St. Helens, Krakatoa, or even Tambora. Those were just little flares next to what simmers under Yellowstone. A massive blast could hurl forth vast amounts of ash alongside stone. Continents would plunge into shadow. 4 years afterward, the atmosphere, thick with sulfur, would chill the planet. Harvests might vanish. Nature's interwoven systems would unravel. Consequently, Earth's climate equilibrium faces upheaval. Still, Yellowstone holds its peace. It lives, though without a sound. Earth swells, then dips. Underneath, molten rock shifts, mirroring the gentle rhythm of sleep. The water in hot springs transforms hue alongside alterations in its makeup. Geysers, silent for years, suddenly erupt, fleeting bursts hinting at what lies below. The park breathes, so researchers watch closely. Each shake, each rise, each shift in what the gases reveal. A network of instruments, sensors, orbiting eyes in space, ground-shaking detectors, collect information that flows in constantly. It builds a portrait of the world's pulse deep below. Even when numbers shift, nobody frets. Yellowstone doesn't threaten ruin. Instead, it demands we wait. Scientists aren't really worried about how often this happens. It's what could happen that keeps them up at night. We can deal with space rocks, given time. We might nudge or shatter them. Yellowstone, that one's different. It's entirely out of our hands. It isn't a goal we pursue, nor a force we halt. Consider it simply the planet exhaling, a gradual process, impossible to counter, completely unconcerned with us. Considering Yellowstone across vast stretches of history shifts its image. It's not so much a danger, rather an instructor, the park reveals just how delicate the ground beneath our feet really is. It's startling how quickly we forget things. Cultures bloom then vanish like mayflies against the vastness of Earth's history. However, beneath Yellowstone, a reservoir of molten rock persists from long before humankind even imagined flame. Should Yellowstone blow, Earth wouldn't finish. Instead, it'd just shift. Another change in the world's long history. However, for people like us, those who label, chart, and calculate, things would drastically alter. It isn't that we exist on Earth. Instead, we're inside her. We move with the planet's gradual spin. Its changes, its wild beating core. It isn't just dread that keeps scientists focused on Yellowstone. The park reveals how mighty our planet is, how long it can wait, also how it restarts. Grasping this reveals a core truth regarding how moments pass. The ground we stand on isn't fixed. Instead, it shifts. It lives, inhales, holds on to things. Each shudder, each puff of hot mist, each whiff of brimstone escaping the ground, Earth shows how making something new also means taking something apart, depending on when you look. Maybe Yellowstone feels deeply unsettling, even beyond the vastness of space or distant, frozen rocks. It isn't something alien. It's familiar. This place breathes. It's ours. A heart beating with fire, observing everything. It holds back, yet guides us forward. You stand on firm earth these days, yet far down, the old flames persist, a low burn, waiting, forever simmering. At sunrise, the steam rising from Yellowstone's valleys looks like breath from a dreaming giant. The light filters through the mist and paints the land in gold and silver, while the distant rumble of a geyser breaks the stillness like a quiet heartbeat. To most who visit, this is beauty, a living postcard from nature. But to those who study it, the beauty carries weight. Beneath every shimmering pool lies data. Beneath every hiss of steam, a message. Scientists have spent decades trying to listen to those messages. Seismographs planted across the park pick up hundreds of small quakes each month. Most are minor, barely perceptible, but together they trace the shifting veins of magma below. The quakes are not random. They follow patterns, like music repeating in complex intervals. They reveal how the land flexes, how molten material presses upward, and how the crust adjusts to pressure that never truly disappears. What fascinates researchers is that these tremors often occur in swarms. Instead of one single quake, a cluster will pulse over days or weeks. Some scientists liken it to the way muscles tense and relax. It may be harmless, or it may be the system testing its own strength. Each swarm adds to an archive of questions, recorded in lines of data, waiting for a pattern that has not yet emerged. Yellowstone's caldera itself, the vast depression spanning roughly 45 miles across, was born from collapse, not an explosion outward, but a falling inward, when the ground could no longer hold the space beneath it. It happened after an eruption so massive that entire mountain ranges were reshaped. Forests were turned to ash in an instant. The land fell, then healed, growing new valleys, lakes, and forests. Over hundreds of thousands of years, life returned as if nothing had happened. That is part of what makes Yellowstone both terrifying and reassuring. It destroys, but it also regenerates. The same forces that erase life eventually create the soil, minerals, and heat that sustain it again. The rhythm of catastrophe and renewal is written into the fabric of the earth itself. We call it disaster when we are caught inside it, but from the planet's view, it is simply continuation. Geologists often work with timescales that dwarf human comprehension. They talk of cycles measured in hundreds of thousands or millions of years. To them, the last eruption of Yellowstone, roughly 640,000 years ago, feels recent. To us, it might as well belong to another universe. Yet, when they hold fragments of volcanic glass or layers of ancient ash, they see evidence of that event as if it happened yesterday. The Earth forgets slowly. Modern instruments can see beneath the park with extraordinary precision. Using vibrations from earthquakes, scientists create images of what lies below. Vast, layered reservoirs of rock that glow faintly with heat. The magma chamber itself may be more complex than any single human organ. It stretches and bends, with pockets of melt and channels of gas that connect deep into the mantle. Within those networks, heat moves like blood, feeding the geysers and springs above. Some researchers have described Yellowstone as a pressure valve for the continent. As tectonic plates shift, the crust thins here, allowing heat from deep inside the earth to escape. This is why the land steams, why the rivers are warm, even in winter, why entire valleys shimmer with vapor. It is not a threat, but a balance. Yet like all balances, it can shift. If more magma were to rise quickly, the delicate system of release and restraint could falter. What troubles scientists most is that the signs of such a change are subtle. Pressure may build quietly for centuries before showing itself. A sudden surge of heat might awaken dormant vents, alter the chemistry of springs, or change the frequency of earthquakes. But there are no guaranteed warnings. The system does not speak in simple language. And yet, in all the quiet observation, there is something deeply human about this study. The scientists who come here are not just watching for disaster. They are listening to the pulse of a living world. They walk the same trails where early explorers once carried notebooks and compasses, sketching the unknown. The difference now that they carry instruments that can detect invisible movements and whispers from beneath the crust. Still, the feeling is the same, all mixed with humility. Occasionally, teams drill small holes to collect coarse samples of the rock. The heat often rises so intensely that equipment must be cooled constantly. These samples reveal minerals that form only under incredible pressure. Each one is a fragment of time, a record of temperatures and chemical reactions that shaped continents long before cities existed. Yellowstone reminds humanity of its fragility. In the presence of such forces, our towers, technologies, and histories feel brief. But it also reminds us of endurance. The park has seen countless ice ages and thaws. It has survived impacts, floods, and the migrations of countless species. Through it all, the geothermal heart beneath it continues to beat. Some scientists have wondered aloud whether the Yellowstone system plays a larger role regulating the planet's surface heat. By venting energy through geothermal activity, it may prevent deeper pressures from building uncontrollably. If that is true, then even its potential violence serves a purpose. The Earth, through Yellowstone, might be balancing itself in ways we do not yet understand. From space, the park looks like a patch of green veins running through the Rocky Mountains. Satellites detect minute changes in elevation, measuring them in millimeters. A slight swelling here, a faint subsidence there. Together, they map the breathing of the land. What is most striking is a consistency. Even after millennia, the pattern holds. Expansion, contraction, stillness, movement, a rhythm older than our species. For those who live nearby, Yellowstone's presence becomes something almost spiritual. It is not fear, but respect. The ground itself teaches patience. Life around the park moves at the same pace, slow, deliberate, in tune with the seasons. Every eruption of a geyser feels like a lesson in release. Every hot spring, a reminder of the invisible foundations beneath all life. As night falls, the stars appear sharp over the vast plateau. The same stars that watched the last great eruption still hang above. The land below them has changed many times, yet the pulse remains. Heat rises quietly through the soil. Water hisses. The park dreams on, and in that dream, humanity listens. The heart of Yellowstone beats slowly. Beneath its serene forests and open skies, movements occur that no human can feel directly, yet all depend upon. Magma shifts in deep chambers. Water seeps down through cracks and returns as steam. Minerals form and dissolve again, painting the ground with the soft pastels of sulfur and iron. From above, it is a landscape of calm beauty. From below, it is a living organism of heat and pressure. Scientists describe the land as restless. Every few years, the ground beneath Yellowstone rises and falls by inches. Trees tilt slightly, shorelines change shape, and geysers shift their rhythms. It is not chaos. It is the earth breathing, This slow swelling and sinking is called uplift and subsidence, and it tells researchers that molten rock is moving in vast quantities beneath the surface. Not an eruption, not yet, but a reminder that deep systems are awake. For most people, Yellowstone is a place of wonder. They come to see Old Faithful erupt, to walk through the steam-filled valleys of Mammoth Hot Springs, to stand before the Grand Prismatic Spring, where colors radiate like light through stained glass. They photograph the bison grazing near boiling pools, unaware that these plains once lay under a sky filled with ash, where rivers of fire once ran. Geologists read the landscape differently. Each ridge, each exposed layer of rock, carries an imprint of violent transformation. The soft rolling valleys are remnants of collapsed calderas. The crystalline deposits on the ground are chemical signatures left by hydrothermal reactions that occur when magma heats groundwater. The park is a museum of ongoing creation, preserved in silence. What makes Yellowstone more concerning than asteroids is not just its destructive potential, but its subtle unpredictability. Asteroids can be seen, their paths calculated. They move in the open, where telescopes can track them years in advance. Yellowstone works in secrecy. Its signals are deep and complex, often disguised within the noise of natural cycles. An eruption could build for centuries unnoticed, or quiet for millennia, after giving signs of restlessness. Beneath the park lies an immense magma reservoir, not a single, hollow chamber of molten rock as once imagined, but a complex network of partially melted stone and superheated fluids. Recent imaging using seismic tomography reveals two main layers, one about 5 miles deep, another stretching to nearly 30 miles below the surface. Combined, they hold enough material to reshape continents. Yet most of this magma is to crystallize to erupt. The system is alive, but not ready to move. Still, the knowledge of that potential humbles even the most seasoned scientists, because all of Yellowstone's known eruptions have changed not just landscapes, but climates. When the last great eruption occurred, the ash traveled across half of North America. It buried regions of modern-day Nebraska and Kansas beneath layers several feet thick. Fine ash circled the globe, dimming sunlight and cooling the planet. Life continued, but changed. Ecosystems had to begin again. Today, we live in a world that relies on stability. Our food chains, our transport, our communication, all depend on predictable seasons and clear skies. A supervolcanic eruption would challenge that balance. Crops could fail for years. Global temperatures might drop by several degrees. Air traffic would halt. The sky itself would become a veil of suspended dust and sulfur. And yet, life would persist, just differently than before. Within Yellowstone, the present is layered atop deep time. The obsidian cliffs that rise above the rivers were once molten glass, formed when lava cooled so fast it had no time to crystallize. Early humans used this same obsidian for tools, sharp and strong. Even in its most violent moments, Yellowstone has given as much as it has taken. It has shaped species, guided migration, and left behind resources that fuel survival. Many of the park's geothermal features, the geysers, fumaroles, and mudparts, are direct outlets for the immense energy below. They act as safety valves, releasing pressure that might otherwise build. Scientists monitor them closely, not in fear, but in reverence, because each eruption of a geyser, each surge of a hot spring, is the Earth's way of whispering its temperature. When satellite images are taken at night, Yellowstone glows faintly warmer than the land around it. The ground radiates heat absorbed from the vast reservoirs beneath. It is like standing on the lid of a slow-boiling pot. The Earth, careful and methodical, keeps releasing just enough to maintain balance. But if that balance were to change, if new magma were to rise faster than the land could release its energy, then the pulse could quicken. Some scientists compare Yellowstone's cycle to the breathing of a star. Long periods of quiet, interrupted by brief moments of blinding release. These are not acts of violence, but of renewal. Just as the sun's flares feed the magnetic fields of the planets, so too does Yellowstone feed the evolution of landscapes, climates, and life. Without these forces, the world would be static, lifeless, and still. So the question is not whether Yellowstone will erupt again. It will. The question is when, and what kind of world will exist when it does. Humanity may have changed by then. New civilizations, new technologies, perhaps even colonies beyond this planet. Yet, wherever we are, we remain connected to the same core beneath our feet. To study Yellowstone is to accept humility. We are temporary beings on a planet that measures time in magma and stone. The supervolcano does not threaten us deliberately. It simply continues its rhythm, a cycle written into the planet's crust long before our species learned to speak. When scientists visit the park, they often describe a strange feeling, not fear, but awe. To stand near a geyser and feel the warmth of the earth rising beneath your feet is to sense the depth of time itself. It is a reminder that this planet has always been alive, that it remembers more than we can ever know, and that everything we build rests upon a world still forming. If asteroids are symbols of external danger, Yellowstone is a mirror held beneath us. It reflects what we often forget, that our home is not a static rock drifting in space, but a living, shifting being, one that breathes through heat and stone, one that can both nurture and erase. The air at Yellowstone carries that knowledge. It hums in the silence between geysers, in the sulfur rising from unseen depths. It tells a story that began before memory, a story that will continue long after us. And still, life walks across it. Bison graze, trees root deep, rivers carve paths through ancient ash. Even as the magma moves below, the world above continues its quiet rhythm. For now, the land sleeps, but beneath, the heart of the earth is still awake. In the stillness of early dawn, Yellowstone seems eternal. The rivers glide in silence. Elk cross the misted meadows. The air trembles faintly, with heat rising from unseen vents. Yet beneath this calm lies motion. Constant, patient, unstoppable motion. The kind that does not rush, but reshapes the world grain by grain. For centuries, people have looked at this land and felt that something beneath it was alive. Indigenous nations who lived here long before the park was named saw the steam as breath and the geysers as sacred release. Their oral traditions spoke of the earth's inner fire as both giver and taker of life. It cooked the soil, warmed the waters, and renewed the land after destruction. These were not tales of fear, but of respect. To live near such a force was to understand balance. When scientists began studying Yellowstone in earnest, they found themselves echoing that same reverence, even if expressed in different language. Seismic instruments, gas sensors, and satellite data became modern forms of listening. The Earth, after all, still speaks, just not in words. The data reveals slow shifts in the crust, small pulses of uplift, faint tremors that ripple like heartbeats through rock. Each reading tells a story about the immense energy hidden below, about how heat flows through cracks and fractures, turning groundwater to steam, about how molten rock rises, cools, and sinks again. What seems static to us, a mountain, a meadow, a lake, is a fluid system of energy in conversation with itself. Scientists often speak quietly when they describe this. It is not drama they feel, but humility. The Yellowstone system is vast beyond measure. The magma chamber stretches 4 miles, a living architecture of heat and pressure. Every quake, every geyser, every plume of steam is a brief signature from that deep structure. Occasionally, satellite images show the ground swelling slightly, then subsiding again months later. It is not yet danger, but it is motion. One researcher compared it to watching the chest of a sleeping animal. The movement does not mean awakening, but it reminds you that life persists beneath the surface. Despite its stability now, the history of Yellowstone is written in cycles of eruption and calm. Each eruption remade the continent, sending ash across the skies and cooling the climate for years. Yet life always returned. Forests grew again over the scars. Rivers carved new channels through the cooled lava. The land never vanished. It simply changed form. This perspective shapes how scientists approach the next question. Not if Yellowstone will erupt again, but when. The answer is not measured in human lifetimes. It stretches into epochs. There is no precise countdown, only observation. The Earth moves in rhythms we can sense but rarely comprehend. That humility may be what separates panic from understanding. To study Yellowstone is to learn the language of patience. Each day, researchers test the water's chemistry, measuring the gases that rise from its depths. In these samples, they find stories of ancient magma mingled with modern rainwater. Every droplet carries memory of fire, of time, of transformation. In this way, the park becomes not a threat but a teacher. It shows how destruction and renewal are partners, how the forces that can undo life also create it, and how all living things, from microbes near boiling vents to the forests miles away, rely on the same cycle of heat and release. In many ways, this is what scares scientists most. Not the idea of apocalypse, but the quiet reminder of scale. Yellowstone places humanity in context. It reminds us that the ground beneath our feet is alive in ways we cannot control, that civilizations rise and fall in the pause between geologic breaths. At night, the stars hang steady over the dark rim of the caldera. Steam rises like the memory of creation itself. From a distance, you could mistake it for peace. Up close, you sense the truth. It is not stillness, but balance. And balance, in the living earth, is never permanent. In the stillness of dawn, Yellowstone feels ancient. Steam curls above the rivers. The air hums softly with unseen power. Beneath the calm, the earth breathes. Slowly, deeply, always. For thousands of years, people who lived near this land understood it as sacred. They saw the geysers and boiling pools not as dangers, but as signs, reminders that the earth was alive, creating and unmaking all things in equal measure. The hot springs were healing places. The rising plumes were messages. Every sound, every tremor, was the planet speaking in its oldest language. Today, scientists listen in their own way. They place sensors across the land. Satellites trace the rise and fall of the ground. Instruments record faint earthquakes that move in patterns almost like a pulse. From these signals, they piece together the story of a supervolcano that sleeps but never rests. What they find humbles them. Beneath Yellowstone lies a world of molten stone that stretches 4 miles, feeding geysers, sculpting valleys, and releasing constant heat into the crust. Sometimes, the surface lifts slightly. Sometimes, it settles again. It is not danger, only motion, like the slow breath of something vast underwear. Yellowstone is not a ticking bomb. It is a rhythm. Its eruptions, separated by hundreds of thousands of years, reshape continents and skies. When the last great one came, it spread ash across half a continent and cooled the climate of the planet. Yet the forests returned. Rivers carved new paths. Life continued, reshaping itself around what remained. This is what scientists think about when they speak of Yellowstone. Not just the fear of eruption, but the lesson hidden within it. The reminder that Earth's power is not measured by destruction alone, but by endurance. Every blade of grass, every mineral crystal, every trace of steam is proof that the planet heals itself, again and again. In a way, this is why Yellowstone unnerves even the most rational minds. It reminds us that humanity's age is brief. Our cities, our empires, our inventions, all exist within the pause between Earth's deeper movements. We live in the breath between fire and renewal. At night, under the wide and ancient sky, the caldera sleeps beneath the stars. The air carries the faint scent of minerals and heat. Steam rises like memory from the land's hidden heart. It feels peaceful, but it is not still. It is balance, the living tension between creation and collapse. And that balance is what keeps the world alive. Yellowstone is not a threat to be feared, but a teacher to be heard. It reminds us that the same forces that can unmake life are the ones that give it form. That survival is not resistance, but rhythm, a quiet understanding that everything changes, and that even change itself endures. So, as the wind moves across the sleeping fields and the stars mirror the glow of ancient fires, we can take a quiet breath and remember our place within this long, unfolding story. We are part of the Earth's memory, not apart from it. Thank you for listening. Until next time, sleep well, and good night.